Okay, let's dive in. Imagine reaching out with your bare hand and actually feeling something that's, well, not physically there.
Right, not through a screen or some haptic glove, but just there, floating in the air.
Exactly. It sounds like pure science fiction, doesn't it? But, that line between sci-fi and actual tech just keeps getting blurrier.
Well, what's really amazing is this isn't some far-off concept anymore. We're taking a deep dive today into some really groundbreaking work from Spain.
From the Public University of Navarra, right? I saw that SciTech Daily article.
That's the one. They believe they've created the first ever genuinely touchable 3D holograms.
Touchable. Okay, so we're not just talking about those cool light shows you see, the ones you can walk through.
No, this is different. These are mid-air 3D graphics, proper 3D things that you can actually interact with. Tactile feedback.
Wow. Okay, so our mission today basically is to unpack how they pulled this off.
Yeah, how it works, what makes it so different from, other 3D displays.
And what we might actually use it for. Let's get into it.
Okay, so first off, it's probably good to clarify what we mean by these 3D graphics floating in space.
Right, because people throw the term hologram around a lot.
Exactly. Often, what gets called a hologram is actually what's known as a volumetric display.
Volumetric display. Okay, what's the key difference there? Lay it out for us.
The main thing with volumetric displays is they create graphics that genuinely occupy a 3D space in midair.
So you can walk around them, see different sides.
Precisely. Without any special glasses or VR gear. The researchers call it a come and interact kind of setup. You just walk up, and there's the 3D image.
Makes sense. A shared glasses-free 3D thing.
Mm-hmm.
Now, the article mentioned some existing tech, right? Voxon Photonics, Brightvox Inc.
Yeah, those companies have commercial prototypes. And visually, they're quite impressive. They do create those mid-air 3D images.
There's always a but.
But, according to the Navarra team, the big limitation is the lack of direct physical interaction. Meaning you can see this amazing 3D shape just hanging there, but you can't reach in and, grab it or move it with your hands. It's passive viewing.
Ah, okay. Look but don't touch.
Pretty much. Visually cool, but hands off.
And this new research, they've cracked the touching part.
That's the core breakthrough, yes.
Yeah.
Achieving what they call direct hand interaction.
Direct hand interaction.
Yeah, one of the lead researchers, Azier Marzo, describes it like using your smartphone screen.
Yeah.
Being able to insert our hands to grab and drag virtual objects.
Wow, that sounds incredibly intuitive. You see something, you want to reach out and touch it. It feels natural.
Totally. It leverages our built-in 3D vision and our everyday skills for handling things.
Did they give examples? What could you actually do?
Yeah, they talked about pinching a virtual cube, between your fingers to rotate it.
Okay.
Or even using your fingers on a surface to make virtual legs walk.
Yeah.
Simulating complex motion just by touch.
So it's bringing that physical manipulation into the virtual world, but without needing controllers or special gloves or anything.
Exactly that. Just your hands.
Okay, my mind's slightly blown. How does this work? How do you touch an image?
Okay, yeah, the tech behind it is really clever. The key innovation is something called a rapidly oscillating elastic diffuser.
Right. Break that down. Oscillating elastic diffuser.
Okay, imagine a very thin, flexible screen, super thin, and it's vibrating, oscillating incredibly fast.
How fast?
The article mentions projecting images onto it at, get this, 2,880 images per second.
Whoa. 2,880 per second? Why so fast?
All about tricking your eyes, basically. Using something called persistence of vision.
Ah, like how movies work, kind of? Your brain blends the frames together.
Exactly like that. But in 3D, your eyes and brain can't process individual images flashing that quickly. So this rapid sequence of slightly different 2D images projected as the screen moves.
Your brain interprets it as a solid, continuous 3D shape.
You got it. Like a super high-speed 3D flipbook, creating this illusion of a solid volume of light.
That's really neat. Okay, but the article mentioned earlier attempts used rigid diffusers. What was wrong with that?
Well, the main problems were safety and practicality. If something's vibrating that fast.
You don't want to accidentally touch something hard and fast-moving. Could break it or maybe hurt yourself.
Precisely. Damage to the gear, potential for minor injury, not ideal for something meant to be interactive.
So the solution was make it soft, an elastic diffuser.
Exactly. They did a lot of testing, looking for materials with the right optical properties, but also the right mechanical ones, flexibility, safety.
And they found one.
They did. They swapped the rigid diffuser for an elastic one. Much safer to touch. But,
Another but.
yeah, another but. As Dr. Elodie Boozbib, another researcher on the team, points out, elastic materials deform.
Ah, right. If it's flexible and vibrating and then you touch it, the surface isn't flat or predictable anymore.
Exactly. It bends, it ripples, and that messes up the projection.
So the image would get distorted, wobbly,
Potentially, yeah. So they needed image correction.
meaning they had to figure out how to adjust the projected image in real time to compensate for how the elastic screen was moving and bending.
That's the challenge. It likely involves some pretty complex algorithms, tracking the diffuser's shape constantly, and adjusting the projection on the fly to keep the 3D image stable and accurate, even when you're interacting with it.
That sounds computationally intensive.
Oh, definitely. A very sophisticated bit of engineering on top of the core display idea.
Okay, this is seriously cool tech. What about the real world? Where might we actually see touchable holograms being used beyond just cool demos?
Well, the researchers themselves are really keen on education.
Education, how so?
Imagine students interacting with, say, a 3D model of an engine part, being able to virtually grab it, turn it around, maybe even assemble and disassemble it.
Yeah. Or like complex molecules in chemistry. I remember trying to visualize those from textbooks.
Exactly. Being able to reach out and actually manipulate that virtual molecule, that could lead to much deeper understanding.
Totally. What else?
Collaborative work is another big one. Think about teams of designers or engineers.
Right. Instead of crowding around a screen or everyone needing VR headsets.
Yeah, they could all see and interact with the same 3D prototype floating in the middle of the room, making changes, discussing it much more naturally.
Yeah, I can see that for architecture, product design, lots of fields. The article mentioned museums, too.
Yes. Imagine museum exhibits where you're not just looking at an artifact behind glass.
You could actually interact with a virtual version of it.
Potentially, yeah. Touch a virtual dinosaur bone, spin a virtual historical artifact around. It can make history and science way more engaging.
Definitely more memorable. It sounds like this has serious potential. You mentioned they presented this somewhere important.
Yeah, at the CHI 2025 conference in Yokohama. That's a huge deal in the human-computer interaction world.
So the big tech companies were likely there. Microsoft, Meta, Apple.
The article mentions them, plus Adobe. Their presence really highlights that the industry sees the significance of this kind of interactive tech.
It's not just a lab curiosity then, and it's part of a bigger project, FlexiVol.
That's right. It's funded by the European Research Council, the ERC, which again points to the high level and potential impact of this research. It's a serious undertaking.
Okay, let's try and wrap our heads around this. If we were to boil it down, what are the key takeaways from our deep dive today?
I'd say the biggest thing is the successful leap to a true 3D display you can actually touch and manipulate naturally.
Right. Moving beyond just looking at mid-air images.
Yeah, and they achieve that by replacing those older, rigid diffusers with this clever elastic one.
And solving the tricky problem of image distortion that came with it.
Exactly. That combination, the elastic diffuser plus the real-time correction, is the magic sauce. And it just unlocks so many possibilities.
Education, collaboration, museums. Probably entertainment, too, down the line.
Absolutely. It really changes how we might interact with digital information.
It really does. Just think about that future. Learning, working, playing in these truly interactive 3D spaces you can reach into. What possibilities excite you the most when you think about this? It really makes you wonder.
It's fascinating stuff.
And again, this incredible work is coming from the Public University of Navarra folks, like Dr. Elodie Boozbib, Easier Marzo, and their whole team.
Yeah, and if you want to dig deeper, the SciTech Daily article links to their actual research paper on HAL, and there's a video on YouTube showing it in action. Worth checking out.
Definitely. And hey, if you enjoyed this deep dive into touchable holograms, please do give us a like and subscribe for more explorations of cutting-edge science and tech.
We'd also genuinely love to hear from you in the comments. Let us know what other topics or specific research you'd be interested in us unpacking like this.
And just a quick note, we sometimes mention products or services related to what we discuss. If you happen to check those out through any links we provide, we might earn a small commission. It doesn't cost you anything extra, but it really helps support the show and lets us keep doing these deep dives.
Absolutely. So stay tuned for our next deep dive. We'll be exploring another really fascinating area of discovery.